on the computer. Okay, welcome Claudia, welcome Stephanie, welcome Sean, welcome Linda, and welcome all of you who are watching this as an archived YouTube webinar. This is the week 10 webinar. We're almost done, definitely in the final stretch of the course. And this is a week where we do something. It's one of the most important sections when it comes to using it, that you'll use it later on in life, and you've already seen it before, but we'll get into more details today than you've ever seen or probably ever want to see, but you get to see it anyway because you have to take this class. And that is regression analysis. A lot of people think of it as the best fitting line for data. And that's something we have not done yet, and it is really important. So I'll talk about what it is, and then how to interpret the slope and y-intercept, how to interpret R and R squared. There's going to be a hypothesis test we're going to be taking, and we'll look all about regression analysis. I'm going to do it by example mostly. We don't do a lot of theory in this class. The formulas are really messy, by the way, pretty much for the whole class. So let me ask you, are there any questions before we get started on regression analysis? Once, twice? Okay. Just a note about our big reminder, Project 2 is due when?
Sunday.
Yeah, it's due on Sunday. It's due on Sunday. It's interesting, I'm not hearing you guys as well. I think it's all of you, but we'll see. Maybe I need to increase my volume, see if that works. So Project 2 is due on Sunday, and that's an important part of the grade, so take that really seriously. I've been helping a lot of people already. I've already had a few submissions for the draft, and the goal is you should send me the draft by tomorrow night, because Thursday's a light day for me, so I can actually read it and do a lot, and Friday's a heavy teaching day for me with my other classes. So I won't be able to do much on Friday. So if you send it Thursday night, might be too late. If you send it Thursday in the day, then I have to do all the ones that I'm doing on Wednesday first and you're last. So so Wednesday night's best, So if you've already done it, of course, that's always good too. You can send it tonight, but don't wait until after then if you can. I will be checking the discussion post forums all week, as always. We have, I don't know if, let's see if I can show you. I don't know if you can see that, but it's beautifully snowing right now. So we're supposed to get a lot of snow all week. So if we lose electricity, then of course I won't be able to get online and check. But other than that, I'll be checking pretty often. So that is the plan. I also wrote your final exam. So I put kind of like I did with the midterm where I put a structure, I did a final exam structure too. It's a little more vague because the final exam covers more. So I have to say chapters this, or this. Some of them are more specific, some are more vague. But that's up on the module, on the final exam module, the last week module. That's just a note. It got posted about 5 minutes ago. Okay, so I want to go and I want to talk about, at least for us, and us meaning Lake Tahoe, the most important statistical analysis that is done here. Okay, and I want to kind of show you, and I want to describe it and look at it and even give you a little bit of story on it. Okay, anyone know what that is? You're all being really silent? Oh, I should pop the chat, and no one's typing in chat either. Nobody knows? Okay, I think I'll pop it up. I'll share the screen, and then you'll get it. If you live in Tahoe, you should know. If you don't live in Tahoe, you may not. Okay, so this is a graph of the Lake Tahoe clarity. And that is, again, the biggest thing that people worry about up here in terms of statistics is that they look at the clarity of the lake and they see, is it getting worse? Is it getting better? What's up with the clarity of the lake? And what they did, I'll tell you a story that happened a while back. But if you look at from the very beginning when they first took measurements, and these little dots are how deep you can see when you drop a white dish into the lake. And they take measurements throughout the year. Then they take the average of those measurements, and then they pop that up. And because you're taking an average, then you get a normal distribution. That's a good thing, because by the central limit theorem, the distribution of averages, if you have a large sample size, is always approximately normal. And I really smiled when they told me the sample size they take. Any guesses?
More than 30.
31. So it's like they took my class very clearly. And not all classes do 30, but I think more than half do 30. So they do 31 in each year. At least that's what the scientists told me. And I didn't like talk of that I was a statistics professor. They just told me that. And I'm like, wow, they actually do it right. Most people don't do it right. And what happened is a while back, a few decades ago actually, the president of the United States came to Tahoe. And they showed in the picture. Now, of course, the picture doesn't show all the dots because, they didn't know the future. And we saw that the clarity was not doing very well. Now, it may look like it's getting better, but this y-axis is backwards. High numbers are low, low numbers are high. They do that to make it look like the lake. And what they did is they performed what's called regression analysis. They looked at this graph, and they looked at the data, and you could see that some years the lake clarity got better, and some years the lake clarity got worse. But if you look at the trend over time, and that's what you want to look at. When we're doing regression analysis, we're looking at trends. We're looking at what can we say about the y value as the x value increases. And it was very clear that as the x value, which was the year, increases, so as time increased, the y value, it may feel like it went up, but remember, everything's upside down. The y value goes down. So notice that in the mid-1960s, the clarity in meters was over 30 meters. And then if you look at around 2000 or so, it's way worse than 30 meters. It's more like 20 meters. So the clarity was declining very fast. And the trend was not like every year it did the same thing, but it definitely saw a trend. And what we can say is based on this trend, I can see it. You won't be able to see it yet, but hopefully by the end of studying this chapter, you'll realize that the R, first thing, the R is negative because it may not look like it, but the slope of the line is negative because everything's upside down. And second is the data is actually pretty close to being on a line. It's not perfect. So the R value is around 0.8 and a negative 0.8. Negative because you have a negative slope, and 0.8 being close to 1, it means that it's a pretty good fit to the line. I'm not going to get into all the mathematical details on what it means to be a good fit to the line, other than if you see the R value is close to 1 or close to negative 1, then you know you have a good fit. If you see the R value that's close to 0, you have a terrible fit. It looks like what I think of the night sky. You look at all the dots in the sky at night, not tonight because it's snowing, but on normal nights when it's clear, then the stars do not look like a line. They're all over the place. Does that make sense? So that's regression analysis. And it allows us to make predictions. And what I love, because I've been here a long time, is that after the president saw this, fortunately, at that time, remember this was a couple decades ago, we actually had a president that understood science. And that president was Clinton, actually. And that president passed a bill based on this regression analysis and turned everything around, made sure that we had environmental standards. And now if you look at the last 15 years, so now we look at, say, 2003 or so, or maybe 2000 on up, there is no positive or linear trend. As time has gone, the dots are just go up and down. They're not all going up slowly or all going down slowly. It's just scattered. Whereas if you look before Congress did something, we can see a trend of these points going downwards because, remember, upside down. Any questions on this idea? Any questions? And I don't think, let's see. Again, I'm new to the computer, so I got to find it. Oh, there it is. Just a minute. Okay, nothing in the chat. I got to remember to keep looking at the chat. Claudia said Clear Lake, so she knew that. Sorry, I didn't have the chat up. I apologize if I'm missing a few things on the new computer, but I'm getting there. So that is really the point of regression analysis. It allows us to make predictions and to talk about patterns of one variable versus another. So sometimes the X variable is time, and then you can make a prediction, a time prediction. Sometimes you want to find out whether or not one thing tends to go up as the other tends to go up. So for example, it was a psychology lecture I was watching a while back. If you look at children, and you look to see how, kind of on a scale of say 1 to 100, how aggressive are their parents in terms of punishment? 100 means they bruise them and beat them up horribly and probably end up in prison. Okay, and it's really bad for the child. And 0 means that they've never touched the child, not even a little touch, in terms of for punishment. And they wanted to find out, is there a relationship between how they grew up as children and then when they became adults, what they did to their children? And any guess what they found? Any guess what they found? Any thoughts?
The children mimic their parents.
Yeah, so they found out, but now I'm going to say it statistically. There was a positive correlation between the amount of physical punishment children got and the amount of physical punishment they gave to their children when they grew up. Okay? Notice the way I said it. There was a positive linear correlation. Here's what you cannot say. Okay? Whether it's true or not, you cannot say based on that experiment where they just looked at the data, you cannot say that the parents beating the children made the children beat their children later in life. What's wrong with saying that? Yeah, so Claudia says, why not? And the neat thing is that the professor who was doing it, this was, I think, a Yale professor of psychology. I was watching a lecture. And the reason you can't say that is statistics does not give you causation. It only gives you correlations and relationships. It does not say this caused the other thing. If all they did is looked at the data, you cannot say that one caused the other. Okay? There's a chance that one caused the other, but you can't say it from just the data. It is possible that maybe these children were like super aggressive children, the ones that got beaten a lot, and that's why they got beaten, and then they grew up and they were super aggressive and they beat their kids. Okay? Maybe, maybe not. The point is you can't look at just data. You have to do more than that. Okay? And things you can do is you can do a randomized control study we talked about in the week 1. You can see if there's some kind of brain thing that goes on, where you're actually doing biology instead of statistics. But statistics by itself, unless you're doing a control study, does not give you any causation. And I will let you know, I'll warn you, I always test about this on the final exam. Okay, so you have to be able to refrain from using words like cause and because, or if this happens, then this will happen. What you can say is that there's a tendency for higher values of X to have higher values of Y. So you have to get the language right, and that's really, really important. Any questions on that? Okay, so just a minute. Okay, so now that I've kind of given you a little intro, a little, to me, to Lake Tahoe people, this is important, is the clarity of our lake is our number one thing. If our lake becomes murky and gross, that is the worst thing that could happen to our town, basically. So we don't want that to happen. So they do lots and lots of statistics, and they're always doing statistics. And I've been part of it, which is fun too. Okay, so I want to share my desktop differently now. Uh-oh, where is it? There it is. I wonder if I can move it over. Oh shoot, it's not what I want. I apologize, it's a new computer, so I'm still working on it. And there it is. Okay, so here's a question we have. Okay, suppose that the equation of the regression line that models the relationship between the amount of time in hours a person practiced shooting free throws and the percent of successful free throws, it's hard to say, percent of successful free throws, Y, is given by, oh, it didn't paste. Uh-oh. Just a minute. Let me get my original copy. I did copy and paste, and it didn't paste. Again, I'm still learning this computer. So I'm going to have to write this in. And in a minute, is it brushes maybe? I just want to do a pencil. Hopefully that'll work. Y with a hat is equal to, and then it's 14. So now let's go text. (14 plus 0.4). Is that not showing? All right, it's black, black. 14 plus, let's see if this works again. I apologize if you can't see this. 0.4 x. See if I go that, it worked. Good, it did work. Okay. So that is the equation of what's called the regression line. So we saw when I showed you the late clarity, you had a bunch of dots. And the idea is you want to take those dots and you want to draw the line that best fits those dots. So let's suppose that line is 14 plus 0.4x, where x, again, is the hours of practice, and y is the number of free throws. Any questions on that? Okay, and r is 0.85. So part A is interpret r squared in the context of the study. So here's one of the easiest things I'll ever say in this class. Okay, and I bet you can guess before I even say it. If I give you r is 0.85, how do you think you find r squared? Yeah, you square it. So what do you get when you square to find r squared? This isn't hard, I promise. Yeah, I like to write it as 2 decimals, and I'll explain in a bit. So let me write this out, and let's see, I missed. Oh, well. So r squared, oh, now you can see it, I think, right? I don't know what happened before, is equal to 0.72. Okay, so we found it, but we got to interpret it. The interpretation is pretty deep. So let me say it first, and then I'll write it out. So the idea is, again, this is basketball season with March Madness, so I throw one in here. Okay, and by the way, I don't know that much about basketball, although I did coach the UCLA basketball team when I was there. But I coached them in pre-calculus, not in basketball. I tutored them, or I taught them their pre-calculus class. But I'm really not a basketball player. But what we can say is that if you look at free throw percent, and just look at general people, then there's a pretty big variation from one person to another. For example, my free throw percent would be really low because I suck at basketball. Okay, whereas who knows, maybe Claudia's free throw percent might be 98% for all I know. Okay, there's going to be a big variation from one person to another in free throw percent. But if you only focus on the group of people that have had a certain amount of practice, then that variation is going to be less. So people like me who never practice, we all are going to suck, and we're all going to be between 0 and 10%. Does that make sense? So that variation for just those who never practice is really small. Similarly, if you look at the people who practice 200 hours, then that variation is going to be also smaller because they're all going to have a really high free throw percent. You see that? So our R squared is 0.72, or about 72%. So what we can say is a reduction in the variation in the free throw percent if you only focus on those who have a specific fixed number of practiced hours. That reduction in variation is 72% on average. Any questions on that? I'll write it out in a minute as soon as I get my water. Okay, so let's write it out. That's probably the hardest part of the entire lecture today is R squared. So there is, I don't know why I don't need italics. Let's try that. There is a large variation in the percent free throw, or I guess successful free throw. Percent in the whole population. But if you just look at the group of people who have a fixed number and that means all the same number of practice hours, then the variation on average is reduced by 72%. Any questions on this? Any questions? So what it is that if you have a high R squared value, then that tells you that this data is, the regression line is useful. So knowing X helps you get a better handle on Y. So if we know how many hours somebody has practiced, then we have a much better idea of how good their free throw percent is. Because when you have a smaller variation, that means you know a lot better what that person's Y is, or free throw percent in this case. Anybody lost on this? Then the hard part is, will you be able to do this yourselves with a different question and understand it? And that's the main thing. Okay, unlike part A, part B is very simple. Okay, but it has a little math, but simple math. It says use the regression line to predict the successful free throw percent for a person who has practiced for 40 hours. So notice the regression line equation is 14, y hat equals 14 plus 0.4x. Okay, the amount of practice someone has, that's x, right? So we want to predict y. So any guess on what we should do? The hint is it's easy.
Times it.
Yeah, just plug it in. So for part B, is that y, and it's y hat. I'm just going to write y h-a-t, y with a hat on it. It's easier to type that way. That is going to be equal to 14 plus 0.4 times x, and x was 40. And what that is, let's see, 40 times 0.4 is 16, 16 and 14 is 30. Any questions on that? So someone in their entire life has practiced for 40 hours, they are expected to have around a 30% free throw success rate. 40 hours is not that much for a lifetime of practice. Any questions on that? Okay. All right, part C is interpret the slope in the context of the study. So yes, you do need to know algebra and you need to remember basic algebra, especially today. So who remembers how to find the slope if you're given the equation? The hint is it's very easy. And what is the slope? Looking for a number. I'm looking at my chat, not seeing it. Hopefully you'll be typing something in soon. So what is the slope of the regression line?
Is it the 1 or the negative 1?
What is it? Yeah, there you go. Stephanie's got it. 0.4. It's the number in front of x, right? Y equals mx plus b. Okay, but I want to warn you, in statistics, we don't call it mx plus b, we call it a plus bx. Just to confuse you, just kidding. But that's what the calculator does, so I better do it that way too. Okay, so it's a plus bx. There is a reason, but it's too hard to explain. So the first thing is, we know the slope is, type this out. So we know that the slope is 0.4. Okay, now the next question I have is, what is the slope in terms of some words that you might have learned in your last algebra class? When you think of slope, what words do you use to describe slope? 3 words, that's a hint. Everyone knows it. Just have to bring it back from the back of your brain. Nothing too technical. Literally 7th grade math, 8th grade math. For me, it was, I think, 9th grade because I'm older. Those days we learned it later. You guys remember? When I say it, you'll all agree that you remember. Okay, I don't see it. So let me type it out. Rise over run. Do you remember that now? I'm sure you've all heard it. That's like one of those like classic math things. Okay, now rise is the change in y. And run is a change in x. Any questions on that? So I'm just going to go through the idea of how we can come up with a sentence to interpret the slope. Well, the change in y is successful free throws. So how much the free throw percent has changed when and X is going to be the hours practiced. Increases. Any questions on that? Okay, so now there's a couple choices. I think I'm going to, one way of doing it, we have 0.4, and that's not a fraction. How do you make that a fraction? So write in the chat box what fraction that is. I'm waiting. I know you guys can do it. There's a few good answers. Maybe I need to put it in. Maybe you don't remember. So the easiest way, I think, is to say 0.4 is equal to 0.4 divided by 1. Any number could be written over 1, right? So now we can interpret this. The rise is 0.4, the run is 1. So that means as follows: if the X value changes by 1, the Y value tends to change by 0.4. Now be careful, you can't say then it will, because that's causation. So let's write out what we've got. We can say that for every extra hour a person practices, their percent of successful free throws tends to increase by 0.4% on average. Any questions on this idea? Okay, so I want to underline a few important words. So let's see how I do this. Brushes, I guess I can do. So one biggie is tends to. Okay. Another is on average. Okay. What you cannot say is that if somebody practices 1 more hour, then their successful free throw percent will go up by 0.4. That you cannot say. You also cannot say that if you practice more, then you will have a better free throws percent. You can't say that because those are causation words. So you can say those who practice more tend on average to have a higher free throw percent. That you can say. Any questions on that? Okay, so the next one is interpret the y-intercept or explain why it has no practical meaning. All right, so the first thing, this is something you should all know from beginning algebra. Based on the equation, what is the y-intercept? Good. Stephanie remembers. The y-intercept is equal to 14. Okay, now let's see if you can remember, math-wise, what does that mean? What does the y-intercept do math-wise? You may or may not remember this, but it was important. It was algebra. So what that says is that when x is 0, y hat is 14. That's the y-intercept. It's the value of y when x is 0. Do you remember that from algebra? Okay, so now what we need to do is we need to do a couple things. One, we have to see if it makes any sense. So here's reasons why things may not make sense. One is x equals 0 may or may not make sense. Sometimes for certain problems, it doesn't make any sense to plug in 0 whatsoever. Okay, it just has no meaning. Sometimes the 14, the y hat, doesn't have any meaning. Does that make sense? So you always want to look at it. Does it make sense for x to be 0 in this case? Can that happen? Are there people with a 0x? Any thoughts? I'm not seeing you all jump in, but you should. Hopefully I didn't confuse you all. Okay, what is x? X is the hours a person practiced throwing free throws.
Yes.
Can that be 0?
Yes.
Yeah. It does make sense for someone to have no practice throwing free throws. There are people like that. Not too many, but there's some. Okay? Does it make sense to have a 14% free throw percent? Can that happen? Yeah. If you had a negative value, you would say it had no meaning. You can't have a negative free throw percent. Do you see that? Or if it was over 100, you can't have a over 100% success rate. So you always look at the numbers, and if they have no meaning, then you just say it has no meaning. The other thing, which you can't see from this, but if the data values that they collected are nowhere near 0 for x, then you shouldn't be using the regression line. So you only use the regression line to predict things that are somewhat close to the data values you have. Does that make sense? Okay, so this time it does have meaning. Now we got to write down the meaning. So if x is 0, that means they've never practiced free throws in their lives. So what we can say is that the best prediction for people who have never practiced is that they will have a free throw percent, a successful free throw percent of 14%. Any questions on this? Any questions? Okay. I don't know. Yeah, we might. But by the way, I hope you're all paying attention, because you all have to be able to tell me an answer, because I want to do one. And I want to show you how to do it with a calculator. Okay. So what I want to do is, maybe I'll even ask you, any curious things that you have. Regression analysis has to be 2 quantitative variables. That's the important things. Maybe something you think as, one changes, the other one might be likely to change also. Anything that you're curious about? Yeah.
The amount of earthquakes in Alaska have any relationship, any relative correlation to the amount of earthquakes in Japan?
That is very interesting. But I want to do a survey of you guys. And that will take some while to get online and figure it out. I just want to ask you a question and have you give me two numbers.
Oh.
Two questions. And by the way, my rule is that you have to give me two numbers, but if you don't feel comfortable, you don't have to give me the truth. Just make it somewhat reasonable. So if I ask you, you know, what age were you when you had sex the first time? Don't give me 375.
That is so inappropriate. Okay.
Anything that you're curious about? All right, so maybe I'll do one. And I'm going to set up my calculator as we go. And hopefully this will work. This is a new calculator program. It'll look different than the last one. Okay, so what I'm going to do is I'm going to go to Stat. And I am going to go to Edit. And these are empty because it's the first time I've ever used this calculator. Yeah, online at least. And usually you're going to erase, you're going to clear L1 and clear L2. You should know how to do that now. Okay, so what I'm going to ask you, I'm going to ask you two questions, and you have to tell me the answer. I hope you're all paying attention. Some of you have been a little quieter than others. You either got to type it or say it. So the first question is, at what age did you first experience your first passionate kiss? Passionate means not your father kissed you on your forehead. That's not passionate. Okay? And the second question I have for you is, what age did you take your first college class? And what we want to do is there some correlation between that? Okay, so you have to give me both answers at the same time, otherwise it's going to be hard to see. You just give me numbers, so you got to give me both answers. So if you don't just give me one, retype, so I'll know which one you mean. So go a number and then another number in the same thing.
Way too long ago. I can't even remember.
All right, you just have to give me a reasonable answer because I want to show you how to do the calculator. Okay, give me something. Okay, and I'll give you mine too because that's fair. So if we go here and go to L1, I'll start with me, because I can tell you. I was 13 when I experienced my first passionate kiss. Her name was Chrissy. Okay, that's something that a lot of people remember. I'm going to hit enter. And L2 is going to be the age at which I took my first college class, and I was 18. Right after high school. Okay, so let's type everyone else's in that I've got. Okay, Sean, we got 22 and 18. So Sean was 22 at your first kiss? And 18 for first college class. Okay, and then we've got, let's see, Claudia, 16 and 18. Oh, Sean changes, let's see. Yeah, there we go. 16 and 18 for Claudia. Oops, do this again. 16 and 18. Everybody was 18. All right, I may have to, oh, good. We got someone that wasn't, that's good. Stephanie, 15 and 17. Okay. And Linda? Just guess if you, huh? Oh, there it is, 16 and 18. Did I get you already?
I don't know.
No, that's another 16, 18. Hopefully we got enough numbers here. There's a lot of 18s. Okay, so here's what we're going to do. And you want to follow along, you're going to go stat. You're used to that button. We're going to go to tests. And definitely the up arrow. Don't go down arrow because it's way down at the bottom. And you're going to go to Lin Reg T test. Not Lin-Reg Tient, that's different. That we don't do in our class. We used to, but we can only do so much. And then I hit enter. Our X list is L1, our Y list is L2, freak is 1. Our beta and rho, that's how you read these, are not equal 0. Don't worry about regression equation. And I calculate. Okay, any questions so far? Okay, I want to write down a few things because I'm going to leave the calculator. We have our t is equal to 0.41 about. We have our p is equal to 0.706. We have our a equals about 17, and our b equals 0.03. Okay, and if I go down arrow, I get r squared equals 0.05, and r is 0.23. Any questions on that? Okay, so now let me change to paint again. Did it work? Uh-oh. Let's try one more time. Okay, change to paint. Let's see if it'll allow me to do the same thing. Get on me with this. All right. Backspace. Got it. Okay. So I want to write down the null and alternative hypotheses. Since this is a statistics class, that's the main thing. H naught. And the null hypothesis, I need to do it with brush, is that looks like a P, but it's not. It's a rho. It's a Greek letter. Okay. So I saw Claudia said, what does it mean? I'm not sure what you meant. I'm not sure what the it is, but maybe we'll get there. So rho equals 0. And then we're going to have an H1. Rho not equal 0. Any questions on that? Okay, so the next thing we can do is we can now interpret all this. We can say, what do we get? Well, we got a p-value, if you remember. P was equal to 0.71. Good enough.
Is that where the line hits the y and x? Is that p rho? Does that mean 0 as in where the...
No, it doesn't. Here's what rho is. Rho is the population correlation. So R is a sample correlation, and you use a Greek letter to talk about the population correlation.
Oh, okay.
Okay. We just don't do that for proportions because the Greek letter for P is pi. And that's too confusing. And in honor of tomorrow, you guys know what tomorrow is? 3.14 pi day. So we're gonna let that one be honorable instead of call it, you know, P kind of thing. Okay. So if P is 0.71, you should all know what happens. What does that tell you?
71%.
It's p value in a hypothesis test. What do you conclude when the p-value is 0.71?
Fail to return.
Fail to reject. We fail to reject. Now you're all supposed to know because we've been doing hypothesis tests for a while now. So we fail to reject. So there is insufficient evidence to make a conclusion about whether or not there is a correlation between the age at which a person had their first kiss and the age at which they took their first college class. Okay, that does not say that there is no correlation. In fact, in our case, we had a sample size of 5. That's never enough to say much of anything. That's just a note. So we definitely don't have evidence. Just find a correlation is not the same thing. There is no correlation. It just means we know nothing. Maybe our sample size is too small and there is a correlation, or maybe there isn't a correlation. We really don't know. Any questions at all on the hypothesis test? So the good news is that the H0 and H1 are always exactly the same. Rho equals 0, rho not equals 0. And the conclusion won't always be fail to reject. Sometimes it'll be reject if the p-value is small. You're used to that. But it's always going to be the evidence to make a conclusion about the correlation between the two variables. Any questions on that? Okay, so pretty important, because if we don't have a correlation, then the regression line is useless. So if we don't have a correlation, don't even try to predict the y value. There's no reason to interpret the slope. There's no reason to interpret the y-intercept because there's no correlation. It doesn't do anything for you. So you only use regression analysis when you have a correlation. So one thing is you want a large sample size so that you can get a p-value that's small. So this was a terrible example in terms of the sample size. 5 is always too small. But we only had 5 people here, so that's all I could do. The other thing is you have to have a normal distribution for each value for all the y's for each value of x, and that's hard to do also. So there's some issues with this. Okay, any questions? Any questions about this? All right, we have time for one more, I think. So let me grab one more. And maybe I'll do a part of it. I need to get rid of this first. That is select. And get rid of that. And now go back here and paste it back in. Okay, suppose that the equation of the regression line that models the relationship between the amount of money X that you charge in dollars at your 1-hour massage. Okay, so we have a business now. And the number of people per week Y who come into your massage shop is given by, and this new system does not copy and paste, so I got to write it out. So I'm going to write Y hat. Is equal to 251 minus 2.5x. Okay, so we could do all the stuff that we did before. Okay, correlation was -0.92. So if you square that, What do you get? That's supposed to be an easy question. You get a calculator. 2 decimals is best. Come on, y'all. 0.83 or so. What do you get?
0.85.
0.85, okay. It's hard to do it in my head, so 0.85. Yeah, that's right. That's right. I did one little mistake. Yeah. Okay, so 0.85 is R squared. So I'm going to say it because I don't want to spend a whole lot of time because we did one like this. And that says that for every extra dollar that you charge in your massage shop, on average, the number of customers who come in, okay, tends to go down by 0.85. Okay? Does that make sense? Now, it may feel weird that you can't have 0.85 customers, but there's an average, so it's okay to say it. It's an average of 0.85. This is very important in business because remember that your revenue is the price times the number of customers you have. So what you want to do is you want to maximize your revenue, okay, and profit eventually. So it really helps to have done a regression analysis. And in fact, do we have any business majors in here? In this group? No business majors?
No, but I ran a business for 30 years.
You ran a business. What do you call the regression line? What do you call the regression line for business? It has a special name.
Profit and loss.
This particular one. It's an econ word.
It's not a profit and loss?
It's the demand curve. You heard of the demand curve before? It's the graph of the price versus the demand. And that's called the demand curve. You've heard of supply and demand? Yeah, so this is the demand. So that's how they come up with the demand curve, or the demand equation, is regression analysis. Okay, so what we can say is that since we got 0.85 for R squared, is that if you look at all the different prices that might be charged, there's going to be a big variation in the amount of customers you're going to get day to day. But if we fix a price, then that variation is going to go down by 85%. So if you run a business, that's really important because if you know how many customers you're going to get, you know your staffing. Does that make sense? So you want a lower variation so you can understand your staffing. Okay, so it's a good idea to fix a price so that you don't have to keep changing the number of people that you have working for you. Okay, how busy is it going to be if you charge $50? Well, you just plug in 50 times 2.5, which is 125, right? So you take 251 minus 125, which is 126, if I did in my head right. So that says that if you charge $50, the best prediction for the number of customers you're going to get is 126 customers. Any questions on that? Big massage parlor, really big. Okay, let's look at the slope, and then I also want to look at the y-intercept since we're here. The slope is negative 2.5. So that says that on average, for every additional dollar that you charge for your massage, you're going to lose, on average, 2.5 customers. Does that make sense to everyone? Okay, what about the y-intercept? Does it have meaning? What do you think? Okay, no one's telling you. What's going to happen to you? You run a business, right? What's going to happen to your massage shop if you charge $0? What will happen to your business? You won't have a business anymore, right? It's not what business is about. So the why-intercept has no meaning because a massage parlor is not going to charge $0 for massage. It won't ever happen because it's a business. Okay, it's not a charity. So in this case, the y-intercept has no meaning. Any questions at all on the regression analysis before I do the main thing of the day? So the secret word for today is tends. Because you want to remember that you use words like tends to and not will become or causes. Okay, when you're using the verbiage, the language of regression analysis. It only talks about tendencies and trends. It does not talk about causes, cause and effect. Because is a bad word because the last bunch of letters are cause. Okay, so I want to again remind you your project is due Sunday. That's a big deal. You're going to have, of course, this chapter for the assignment, and you're going to have a discussion post, okay, for this week. The other thing is you should be starting to think, hopefully next week, you'll send me where your proctor is going to be and who it is and the information. It's really easy if it's the same. You just send me same, and you're done. But some of you may, I don't know, if you happen to be traveling to Europe, you may need one in Europe. So wherever you happen to be. So you have to make sure you have a proctor. And that needs to happen 2 weeks. We're in week 10. So it's the final has to be taken by 2 weeks from tomorrow is the last day, which is March 28th. Will be the end of the class. So any questions at all? Any questions at all about anything about the class or about what we talked about today?
Nope.
Any questions? As always, I'm happy to stay until you have to answer questions. But if you don't have questions, then I'm happy to say goodnight too. Okay, good night, Stephanie.
Thank you.
Thank you. You can send it now if you want. Probably next week's better if you don't mind, because then it doesn't have to sit in my email for that long. But if you're worried about forgetting, you can. Don't send it in the chat. It has to be by email because I won't remember what happened in the chat with all the different chat stuff. Okay, and for all of you who are watching this as an archived lecture on YouTube, thanks for watching. And please ask questions and make sure that you post on the project discussion forum any questions you have. And if you haven't already sent me your project 2 draft, please by Wednesday night is my hope because Thursday I have time. After that, I don't have a lot of time. So Thursday, because I teach all Friday. And then weekend is too late because by the time I get back to you, the project's already due. So please send me questions you have and the draft too, and I'll be happy to look it over, give you some advice on it. So thanks a lot, and have a very good night.